Alright guys, so here is one more example on the quotient rule. I wanted to show you one more that was kind of like what's in your homework tonight. So this particular example is showing us a division problem with exponents, and we've now got our numbers as the bases and not just using variables. So when this happens here, these aren't considered as coefficients because these now are the base that's being raised to a power, raised to an exponent. And so in this case, when we see this kind of thing, I want you to think of this almost as if those numbers are just like variables. In our previous video, one thing we looked at was saying when I had x to the third over just x, that was the same thing as saying that I had like 3 x's being multiplied in my numerator over just 1 in the denominator. And any time that we have the same thing in the numerator and denominator, those cancel and just give us 1. So now this is 1 times x, and our answer for this particular problem was just x squared. So keeping that in mind, if we take a look at this setup and we do -4 quantity squared times -1 quantity to the 5th power times 7 cubed, or to the 3rd power, all divided by -4 times -1 to the 3rd power times 7 to the 2nd power. If we set this up and we want to write it in expanded form like this example up here, what that would look like now is just like this. So now what we're looking at is, it's still, let me go ahead and adjust this a little bit. My numerator is still -4 times -4, there are 2 of them. With my -1, there are 5 of those, and so I've got 1, 2, 3, 4, 5 in my numerator. Sorry about that, guys. So now I have 7 to the 3rd power, so there are 1, 2, 3 7s in the numerator. And then my denominator, we're looking at a -4, so there's just 1. -1 to the 3rd power, so there are 1, 2, 3 of them in the denominator. And then 7 squared, so there's 2 7s in the denominator. Now the purpose of writing this out, sorry y'all. So for the purpose of writing it out in expanded form, sometimes what can happen here is it's easier for us to kind of just see that visual of when things cancel. Remember that when you've got a fraction like 4 over 4, we know that this simplifies to equal 1 because having the same thing in the numerator and denominator is equivalent to just 1 whole. So by doing that now with this fraction that we've set up down below in expanded form, one thing that I'm going to see right here is that when I have a -4 in the numerator and the denominator, those are going to cancel and just give me 1 right here. So I still have this -4 left over, but then this is times 1. And now with my -1s, I see that I have 1, 2, 3 of them that are going to cancel, because when, again, same thing in the numerator and denominator, they cancel. That now leaves me with 2 -1s. With my 7s, I have 1, 2 that are going to cancel, leaving me with just 1 7. Now what we also notice is that all of these things are left over in my numerator as well. So now when writing out my new answer, or at least a simplified version of this, I have a -4, and that is being multiplied times 2 -1s, so that's like -1 quantity squared, and then also multiplied times a 7. So now that I get to this part right here, normally with variables we would stop, because when we write it fully simplified so that everything is only shown one time, we can stop, but again, we don't know at that point the values for x or y. And so in this case, I can actually solve this out. So when I do this, I'm going to say, okay, well, -1 to the 2nd power means -1 times -1, which is +1, because a negative times a negative is positive. So now I have -4 times 1 times 7. So -4 times 1 is -4, times 7 is going to give us a -28. And that's our final answer for this problem.